Good morning, students. I am Nidhi Pagalwadi, your science teacher, Sankalp Learning Solutions. In the last video, we studied regarding the heating effect of electric current. Now we are going to study regarding the practical application, means where we will see that in our daily life. The first one we are going to study regarding the electric bulb, guys. So electric bulb, the first example. So it is a practical applications of electric current, right? Of heating effect of electric current. Heating effect of electric current. So here what happens, guys? Suppose let us consider example number 1 as a bulb. So we know that the bulb, okay? So the bulb is made up of a tungsten wire, right? So the bulb, when we see the bulb, okay, so the bulb will be consisting of a glass. Inside we will be having a tube. Inside we will be having a thin filament like structure which is called as tungsten. So this tungsten metal is there, no, it has a highest melting point at about around 3380 degrees Celsius. Highest melting point. And what happens here, when electricity is passed through the bulb, that is electrical energy is passed through the bulb, so that will heat the filament. When you see the filament or the wire, you can see that it will be having the length will be more and the area will be less. Why? Because when length is more and area will be less, we know that resistance will be high. Resistance is directly proportional to length. Resistance is inversely proportional to area. So it has a high resistance and high melting point. So when electrical energy is passed through it, the electrical energy will be converted into heat energy. So as it has a very highest melting point, it will not melt. So due to that heat, what happens? The filament glows. Due to the heat, the filament glows and gives out light. You can ask me whether this heat energy, as the heat energy is produced in an enormous amount, whether this energy will not affect the glass. No, it will not affect, because the glass, inside the glass, it is filled with the argon gas. Argon gas makes the atmosphere inside the glass inactive. Means the heat will not affect this region. The heat will affect only on the filament. The heat will not affect this region because this will be filled with the argon, which is an inactive element, argon gas. So like this heating effect of electric current gives us light. This is the first one. Second one is nothing but our iron equipment, right? Iron machine. Okay. So in the iron machine, we will be having one nichrome wire we will be having. Okay, one plate we will be having, the other plate we will be having. So it is made up of three stages or three plates. The first one is a nichrome wire which has a great or highest melting point. It is a very good conductor of electricity, so it will get heated up. So when it heats up, it will shift to the next plate. The heat will transfer to the next plate. So this plate should be in such a way that it will transfer only the heat. The current should not be transferred. Because if the current passed, whenever you touch the iron machine, so you may get shock. That is why current should not be shifted here. Only we want the heat to shift. So what happens? This is made up of a material which is called mica. Mica is a mineral which is a good conductor of heat. Mica is a good conductor of heat, but bad conductor of electricity or bad conductor of current. Means it will not pass the electric current, it will pass only heat. Then again the heat will be transferred to the third plate which we will press on our clothes. Like this, the iron machine works on the heating effect of electric current. And this nichrome wire is made up of, it is an alloy, it is made up of nickel and chromium. This is made up of nickel and chromium, which are the good conductors of heat and current. So this heat will be transferred to the mica plate, which will only absorb the heat, not the current. And the heat will be again shifted to the plate which we press on the clothes. This is how the heating effect of electric current works in the iron machine. Next, sometimes in our houses, we heard regarding the fuse. The fuse has been skipped, right? The fuse, the white color one which we will be having in our main electric system of our houses, right? So this white color one which is called as a fuse. So that fuse, inside the fuse, we will be having a thin wire which is made up of a PB, that is lead, which is made up of PB. So this lead has very low melting point. This lead has very low melting point and high resistance. High resistance. Why? Because the area will be less and length will be longer. It will be winded. So high resistance. So when the current flows to the circuit of our house, when the higher voltage of current flows through this fuse, this wire will melt. This wire will melt, and what will happen? It will not conduct, or it will not pass the current further. So when the wire will melt, it breaks the circuit so that the current will not pass further, and it will save our costly appliances like AC, fridge, etc. It will control the amount of heavy current flowing through the circuit because of the lead wire. It melts soon due to the low melting point. That is also an application of heating effect of electric current. But nowadays we have the magnetic thing introduced in the fuse, where if a high voltage of current is passed, the magnetic thing whichever will be there in the fuse will skip. So we will get a sound like tuck. Okay, then all the current inside the house will be switched off. So when we are again rearrange it, again the circuit will be closed, again the current flow will be continued. So like this, we can see many practical applications of heating effect of electric current in our daily life. Let us move to the next concept, the last concept of the electricity, guys. So let me rub this because I want that side, that part. So we know that the heat or whatever the work done, okay, during in the electrical circuit will be in the form of a heat, that is heat energy. So this heat energy at a particular time gives us the electric power. This heat energy at a particular time. So the next concept we are going to learn is nothing but the electric power, guys. Electric power. So this electric power is nothing but the heat energy or the electric energy per time, per unit time. Electric energy utilized per unit time. So what is electric energy here? It is nothing but a heat energy or the work done, right? So electric energy is VIT divided by T. P is, power is denoted by capital P. So T get cancelled, power we can write it as VI. Suppose if you substitute here, P is equal to, okay, so it is I square RT divided by T. So it will become I square R, or P is equal to V square T by R into T. T get cancelled, we can write V square by R. So this is nothing but the electric power is nothing but the electrical energy per unit time. When we come to know its SI unit, the SI unit of power is watt. What? It is nothing but watt. Okay, it is nothing but watt. So sometimes it is measured in terms of 1 kilowatts, or we can say sometimes it is measured commercially Commercially, it is measured in terms of horsepower or 1 kilowatt. 1 HP, that is 1 horsepower, is equal to 756 watts. Right? So in our electricity bills, you can see the electric power is measured, or electrical energy is measured in terms of kilowatt hour. Kilowatt hour. Okay, so this 1 kilowatt hour is regarded as 1 unit. So they will charge for this unit, means they will charge for 1 kilowatt hour. So what is this 1 kilowatt hour? When we simplify, we will get to know 1 kilowatt hour means 1 kilo means watt. 1 kilowatt means 1000 watt into 3600 seconds. So when you just multiply it and solve, we will get 3.6 into 10 raised to 8 watt seconds. Okay, so this is the simplification of 1 kilowatt hour. So this is how power is calculated. This is how power is calculated, and this is regarding the SI units of the power. Here we completed the chapter electricity. In the next session, we are going to start with the new chapter. Until that, take care. Have a nice day. Bye-bye.